Hi, this is Ken Hamrick, founder of Tracetest, here to show you how you can take your existing Playwright test and, with Tracetest, get visibility and testability across your entire system, both front end and back end, all in one test. Is your system instrumented for distributed tracing with Jaeger, Tempo, Honeycomb, or any OpenTelemetry based system? Do you use Playwright? Well, you're ready to go. Tracetest works with these to enable trace-based testing, which uses your existing instrumentation to shine a light in what was previously a black box. When creating a test, you will now see a Playwright integration. With this integration, you can extend your existing Playwright test. Oscar will show you a demo. Let's look at the system he will be testing. It's a 2 microservice system called the PokeShop app. On the left, you see the app. On the right, you see the trace. The API processes a request and validates it. It puts a message on the message queue, and then the second worker process pulls a message off and does the real work. Let's see how Oscar can use a Playwright test to test not only the front end, but also this entire backend flow.
Hello everyone, my name is Oscar Reyes and I'm a lead software engineer here at Tracetest. So as you can see, we're going to be looking at the Playwright UI that we have over here, which is going to be triggering a test to import a Pokemon. Importing a Pokemon is a process, it's an asynchronous process that has two sections. The first one is a frontend or like a service that returns a 200 and puts a message to a queue. We're going to be using RabbitMQ for this. And the second half is a worker process which grabs the message from the queue and sends the information to the database. It also fetches some information to an external API endpoint if the Pokemon information is not part of the database already. So to start with, we're going to be kind of looking at the front-end feature, which is clicking the import button over here, then adding a random ID from 1 to 100, and then clicking the OK button. This will trigger the whole backend process, and we can see the resulted Pokemon as part of the list below. So this is a pretty straightforward Playwright test where we just hover over the import Pokemon, we add the ID, and then we finally click the OK button. Now what we're going to be doing next is I'm going to be stopping the worker. So as you can see, the second half of the process is already off. And if I trigger this UI run again, we will see that the test is going to be passing. And this is because even if we try to kind of validate all of the stuff, we don't have the potential from the end-to-end test to validate that the actual Pokemon was added to a list. Or what happened exactly. We cannot see the Pokemon. We can validate the Pokemon is not there, but we don't know. We don't understand what happened. So what we're going to be doing next is I'm going to be enabling as part of the integration piece for the trace test. I'm going to be showing you more in depth in a few seconds. And I'm going to be running the test again. So in this case, I'm going to be running it from the code so we can see another part of this. I'm going to be running this. As you can see, we have the terminal with the VS Code extension running. And at some point, I would expect to see the resulted from this test. Just a couple of more seconds and we can see that. Poo, 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 poo. Okay, it failed. Now what we can see is the resulted output from the failure, which is test specs are failing. So let's take a look at this run from the link that was generated from the output, the console output. So we follow this link all the way to the Tracetest app. We can see if we move to the test section, we can immediately see that part of the trace is missing, which is the section where we receive the message. So we have this initial service where we validate the Pokemon request. We have the incoming post request. Then we're putting a message to the queue, but the worker section is not here. And we have a section that is failing where we expect an HTTP span to exist on the second half and returning 200. So if we go back and re-enable the worker, just look for that window, and we enable the worker back again, okay, and then we test this, execute this run once more, we'll find the entire trace and the test specs showing all green or the result to be successful, because now the full process and the sessions are will be matching the entire list of spans that are required with the validation. So we have our result on the console output. That is really handy. And then we can open the link. Following this link, we come back to the test section. I will find that everything is green, and even we can see in the code editor that the Playwright test is passing as expected. So everything looks good. So just to encapsulate or kind of summarize, we can see that by enabling end-to-end tests with trace-based testing, we have the power to identify exactly what failed, what problems exist in your distributed system, not only from the browser, but all the way to the backend services or the end of the line. So let's take a look at how this works. If we go back to the code and start doing checking the real thing, the beef and potatoes, we'll find how we're going to implement the trace test with Playwright. So at the top, we are importing our new package called tracetest Playwright. That is an npm package that works for both TypeScript and JavaScript. Then we're going to be instantiating or creating a variable called tracetests with the types that we are importing. Then there would be two steps that we need to add. The first one is in the lifecycle hooks of the script, in the before all section, we need to create an instance of tracetest by passing the token. This token is something that you can create from the tracetest web app based on your environment and assigning the permissions to access the tracetest API for you. The second thing that you need to do is in the before each hook, executing the capture function. This will pretty much add the meta tag with the trace pattern to the HTML that is going to be executed as part of your website, and it's going to be allowing TraceTest to generate a single trace for the entire user process or the entire testing script. That means that if we look back at the UI, you can see all of the spans generated all the way from the front end. So if we have some clickings, if we have some other events that can be added like key down or key up or any user input, and how this interacts with the backend in terms of creating the initial post request to the import service and the entire backend trace as well, from the RabbitMQ spans all the way to the database for Redis, the HTTP request, and the Postgres stuff that we have over here. So that's what the capture method enables. The last but not least is if you want the Playwright test to be failed, or to the script to fail based on the trace-based testing, not only the end-to-end or the front-end tests, you can add this method called summary. So by adding this or waiting for this summary, in the after hook, the script will be waiting for all of the trace-based tests to yield a result. And once the result is ready and traces has everything available for you, it will pretty much crash or succeed the entire script process. In this case, it will allow you to implement this into a CI/CD process where you can have kind of trace-based tests TDD approach. Let's put it like that. And last, but the next part is the Playwright script or the Playwright test, which, as you can see, it's the same test that would you be writing in a regular environment. We're not changing anything regarding with this section. So that means that you can keep writing the Playwright test as you normally would, with no change to the specific section. What we're only doing is kind of leveraging the lifecycle hooks of Playwright, so you can add these trace test functions that will enable you to run trace-based tests alongside your Playwright tests. So yeah, let's just run it again so we can see how this looks like. And with this VS Code editor, you can see what is happening. You can see the output, exactly what things are running, and that will lead you back to the app. So the following part is what happens if I want to keep adding assertions. You can keep adding that. Let's say that I want to test that the specific Pokemon was added to the Postgres database. So I can check for the DB result, or I can check for the table that was used, any stuff like that. So in this case, I'm going to be testing that the name was correctly, in this case is Ekans, sorry. So I can add a test spec over here, and then I can do a JSON path method where I want to check the name, and then I want this to be matching the name of the Pokemon. Pokemon matches the name. And this will immediately yield the expected result if it fails or if it's successful. So I can save this, rerun, and I continue doing the cycle of kind of updating my tests and the expected result based on the assertions that I want, and also based on the end-to-end tests. So yeah, that's it for today. That's what I wanted to show you. Next steps is, if you want to take a look at the documentation, we have a specific recipe and a piece on this on the documentation site, where you can find out more information about all of this, as well as a small example of how you can run this yourself. And yeah, that's it for today. Thank you for watching, and see you next time. Bye.